Hi, everybody. It's Miss Rose. Let's go over the week 7 honors practice problems. Number 1 is a really good problem that looks a lot like what we've done in class, but just with a little bit more to it. So we are given that EM is perpendicular to MO. So I'm going to label my right angle, and then angle 1 is 3x plus 10, and angle 2 is 6x plus 8. So like we keep talking about, you're not always going to use all the information in every equation that you make. So I'm going to stop there, and I know that I can add up those two expressions and set it equal to 90 since the two angles form a right angle. So 3x and 6x is 9x, 10 and 8 is 18. Add them up, set it equal to 90. Let's solve this quick equation. 90 minus 18, 72. And 72 divided by 9 is 8. So let's read the rest of the problem and see how that might help us. So it says AS bisects RAT. So I am going to put two congruent angle arcs on there because that's what we do when an angle's bisected. And then the measure of angle RAT is 112 for the whole thing. So I'm tempted to split that into two parts because it was bisected. So each angle will be 56 degrees because that's 112 divided by 2. And then it says, is angle 2 congruent to angle 4? Well, let's see. Angle 4 is 56 degrees. Angle 2 is 6x plus 8. So let's substitute x equals 8 back in and see if angle 2 is also 56 degrees. 6 times 8 plus 8 is 48, plus 8 is 56 degrees. So the measure of angle 2 is 56 degrees. The measure of angle 4 is 56 degrees. So is angle 2 congruent to angle 4? Yes. Angle 2 is congruent to angle 4 because the measure of angle 2 is equal to the measure of angle 4, which is equal to 56 degrees. All right, let's take a look at the next one. We're talking perpendicular bisectors. So I know that I need the slope and I need the midpoint. So I noticed something funny about A and B, though, is they both have the same y value. What that means, if I draw a quick sketch, I have 111 and 1511. It's going to be a horizontal line. So I really only need to find the midpoint. And then the perpendicular bisector is going to be a vertical line. So I'm looking for an x equals line that passes through the midpoint. So I don't really need to average the 11s because the average of 11 is just 11. But I can average the 1 and the 15. And if I add them up, I get 16. 16 divided by 2 is 8. So the midpoint is 811. And the equation for the perpendicular bisector is x equals 8. All right, let's move on to the perpendicular bisector of BC. This time I don't see any coordinates in common, so I'm going to need to find the slope. y2 minus y1 over x2 minus x1 gives me -4 over -22. Two negatives gives me a positive, so I'm going to want to simplify that. I can also simplify 20 seconds into 2/11. So I don't really have to, but I can. And then the midpoint, I'm going to average the x's and average the y's. So 15 plus -7 is 8, divided by 2 is 4. And then 11 plus 7 is 18, divided by 2 is 9. So the midpoint's 4, 9. So I want an equation for the perpendicular bisector. So I'm going to need to take my slope and do my little switcheroo, -11 over 2. And I'm going to want to use that slope and my midpoint as my point and write an equation for the line. So my first perpendicular bisector was x equals 8. My second perpendicular bisector was that equation in point slope form. And then I want to see where they intersect. Where do they meet? So you would have to normally set up some sort of system of equations. But in this case, I can actually just plug in x equals 8. And whatever y value I get is going to be where they intersect. So I'm going to take this equation and just substitute in x equals 8. Y minus 9 equals negative 11 halves times 8 minus 4. Y minus 9 equals negative 11 halves times 4, which is negative 22. Add 9 to both sides, and the solution, negative 22 plus 9 is negative 13. So they intersect at the point 8, negative 13. And then I put a little fun fact on there. So if A, B, and C were all points on the same circle, the center of the circle would be 8, negative 13. So let me know if you have any questions. Bye.